So this is the last topic in our first unit. That's the basics of measuring instruments. In this, we'll be now today studying the errors in measuring devices. Uh, Simply stating, it's impossible for a measuring instrument to be error-free. Errors will occur in the measurement, in the measuring devices, the measured values. No matter how much care we try to take, how efficient we try to make up the system, there will be slight to moderate error in all measuring devices. Although we can minimize the possibility of the error occurrence by carefully designing the system, by carefully taking the observations extra, but these errors will likely occur still. So there are, uh, broadly stating, we can say there are two different types of errors. One will be the measurement error. Broadly stating, broadly speaking, there will be two types of errors. One will be uh, one is referred to as the measurement error. The second type of error will be because of uh, noise, disturbances, extra. Fine. So there are, broadly speaking, two types of errors: the measurement errors and errors due to noise, disturbances, extra. Now there are different types of measurement errors, also subtypes of measurement errors that we'll be seeing today. These different types of measurement uh, errors can also now be categorized into two types: the systematic errors and the random errors. As far as the measurement errors go, they are simply the errors that occur because during the measurement process. Okay? While we are trying to measure any quantity, errors that will occurred because during that process, they will be referred to as the measurement errors. And broadly speaking, they are of two types: the systematic errors and the random errors. Now again, systematic errors and random errors both have subtypes. Mm, As far as systematic errors go, we can again classify them into four different types of systematic errors. Uh, so firstly, there are errors because of measurement, and there are errors because of noise, disturbances, extra. So these measurement errors are then divided into two types: the systematic errors and random errors. Now, systematic errors are again divided into further types: instrumental errors, environmental errors, observational errors, theoretical errors. While as the random errors, they will be divided into gross errors, blunders, extra. Uh, all other types of errors that are actually undefined in nature can be classified under the random errors. Now, what are firstly systematic errors? Systematic errors are basically those types of errors that take a particular type of value. That means either it will be having a positive value of error or it will be having a negative value of error. It will not take both values, both types of errors at the same time. Either the error will be positive or negative. As far as systematic errors go, they are also referred to as bias error. Fine. So systematic errors, the output reading will either be positive or will be negative. It cannot be that the error will be both positive and negative in the same reading or in the same set of readings, and that will not be happening with systematic errors. Uh, Systematic errors, they are also referred to as bias errors. Now there are different sources of systematic errors that actually lead to the classification of these errors. The effect of environment, the effect of environment on measurement basically classifies our environmental errors. Disturbances in the major system, that means by means of faulty measurement, जो भी measurement में error आएंगे, that will be classified as instrumentational errors. You will be having observational errors. You will be having theoretical errors. You will be having errors occurring because of the wear and tear in the instrument. Uh, Fine. There may be errors because of the resistance of the connecting leads. ठीक है, ये सारे types of errors जो instrument की खामियों की वजह से होंगे, that will be classified as the instrumental errors. All those types of errors that will be taking place because of the effect of the environment on the instrument will be classified as environmental errors. All those types of errors because of the observation in the system, in the instrument, that's actually different from what it should have been. They will be referred to as the observation errors, and there will be theoretical errors because of some mathematical inaccuracies. Will be uh, that will there is a difference between the theory and the practically what will be the values. Theoretically true value and the practical true values will be different because of mathematical modeling inaccuracies. They will be referred to as the theoretical errors. Fine. Uh, तो measurement errors में पहला type systematic errors है. Systematic errors are those types of errors that will either take positive values or negative values. The sources of these systematic errors can be uh, because of the effect of the environment or because of the disturbances occurring during the measurement. Okay? Other types of systematic errors can also include errors in the instrument itself. Say, for example, needle bent है या needle की calibration ठीक नहीं है. ठीक है, fine. Use of uncalibrated instruments, drift in the instrument characteristics, as last time we defined as the zero drift and the sensitivity drift, taking place because of the sensitivity to disturbances. So if there is a drift in the instrument characteristics, the static characteristics or the dynamic characteristics, that will also lead to these types of errors, or because of poor cabling, connections properly connected नहीं थे, कहीं पे wiring loose थी, तो उसकी वजह से भी error आ सकता है. So all these types of errors will be referred to as the systematic errors. Right? Now these types of errors will definitely take either the positive values or the negative values in the same set of readings. They will not be taking both positive and negative values. How to reduce these systematic errors? There can be, as I suggested, uh, there may be errors because of bent needle. ठीक है, ऐसे errors को निकाल पाना easy है. Simply make the correction in these devices. Bent जो needle है आपकी उसको correct कर दो. जो आपकी cabling poor होगी, make have a proper cabling fine. These things can be easily rectified, and they are not also expensive in nature, so we can uh, remove these faults easily. As far as other types of systematic errors will be concerned, we can reduce them by properly designing the system in any of these fashions. Uh, Fine. Design the instrument. Make sure that the system design is robust. Mathematical model that we are designing the system for should be robust as well. Okay. Second thing is proper calibration should be done. Make sure that the zero of the measuring device is calibrated properly. या फिर अगर zero device नहीं है, there is some other type of indication. It's a different type of indicating instrument. So make sure that you are calibrating your device properly. Fine. Method of opposing inputs. That means, say for example, your environment is resulting in positive error. There is a, because of the effect of environment on the system, there may be some error taking place. Now we know the effect of the environment. We can make sure that we are applying an input that will oppose the environmental effect. ठीक है? So method of opposing inputs. Make sure that you are applying a type of input that will actually nullify the effects of the environment on the instrument. Uh, you can design the measuring system keeping a high. Uh, First of all, make sure that you are designing a feedback based measurement system, and then try to properly tune it. That means use proper values of gains extra, so that the error in the system measurement is actually reduced. We can reduce the measurement errors also, the systematic errors, by properly filtering the input variable to the measurement device, by properly filtering out the output value from the measurement device. Fine. Also, we can go for manual correction of output readings. We may know that there is some uh, constant steady state error in the output value. So we can go for manual correction. We know that there is a constant steady state error of 2 units. So we can accordingly adjust the corrections in the output readings, or as also described earlier, that we can nowadays go for smarter devices, go for better control systems. So make we can adapt, we can adopt instruments that are adaptable uh, to the environmental effects, that are adaptable to these measurement errors, that have better sensors. So in short, they will be intelligent devices that will take care of the measurement errors on its own. So these were the first types of errors. They are the systematic errors. Systematic errors will take only positive or negative values, and these errors occur because of the effects of environment, or because of the malfunctioning of the instrument itself, or improper connections of the instrument design, improper instrument design. All those characteristics, all those uh, errors because of the instrument itself will lead to these types of errors. Second types of Second type of error that are found in measuring devices are random errors. As suggested, random errors may be categorized into gross errors. They may be categorized uh, into blunders. They may be some other undefined nature of errors that are also classified as random errors. So random errors, they are also known as precision errors. Uh, Now, in case of random errors, what will be the nature of these errors is that it will be taking both positive values of errors as well as negative values of errors in the same set of measurement. We may have both positive values of errors as well as negative values of errors. In case of systematic errors, we were getting either positive values of errors or negative values of errors in the same set of readings. But in case of random errors, we'll be getting in the same set of readings both positive as well as negative values of errors. Now, one of the main types of random error is actually the gross error. So gross error is nothing but uh, error that is taking place because of improper human observation. Okay? The measurements, the measurement error that takes place that arises because of improper reading by the human observer. uh, ठीक है जो भी ऑब्जर्व कर रहा था सिस्टम को he has inaccurately taken the readings or the, such type of errors are referred to as gross errors, and as said gross errors are one type of random error. So how to balance the random errors, how to overcome the random errors is by taking a number of measurement readings repeatedly and extracting a value by the average of those uh, readings. Fine. They may be, as I said to you, error यहाँ पे both positive होगा as well as negative होगा, and there's an equal chance of getting both positive value of error as well as negative value of error. So by taking the mean value of the readings, we'll actually be getting the true value of the readings. Right? So we'll be taking a number of observations and taking the average of those observations. The average of those observations will be actually uh, accurately depicting the true value of the output error. Right? Uh, Gross error, physical errors in the apparatus or the calculations or in the recording measurement outcomes taking place wherever the observer might study or record ड्यू टू रिड्यूस्ड वेव. ठीक है, ऑब्जर्वर की खुद की गलती की वजह से जो एरर्स सिस्टम में आ जाते हैं उनको हम ग्रॉस एरर्स बोलते हैं. और उन ग्रॉस एरर इज बेसिकली a type of random error. So there are actually just two types of measurement errors, systematic errors and random errors. Then they have subtypes. Systematic errors, they take only one set of error values. Random errors will take both set of values. Now, this is just the basics. Uh, how to calculate errors in the measuring devices. We can calculate the error by in either in terms of absolute values or in terms of relative values or simply by taking the percentage value of the error. So absolute value of error is simply this is absolute error. It's simply the measured value of the reading minus the exact value, the modulus of this. ठीक है? As far as percentage error goes, it's Vm minus Ve, again the mod of this over the actual value multiplied by 100. So that gives you the percentage. And relative error is simply the absolute value of error divided by the actual value. So these are some calculations that will be required for. Um, they may not be used everywhere, but they are basic. Uh, these are basic formulas that are required for calculation of different errors. Right? So you have this. Fine. So I hope errors are clear. You have two types of errors: systematic errors and random errors. Systematic errors take take either the positive or negative values. Random errors take both types of values. Now, systematic errors के causes, they can be environmental causes, they can be the inaccuracy with the instrument itself, uh, faulty nature of the instrument, faulty design of the instrument. All those things will lead to systematic errors. Random errors will be because of, say, for example, human interaction with the device. The observer may not be properly measuring, or because of its own reduced capability of the observer, there may be errors, and these types of errors can be both positive as well as negative for the same set of readings. Right? Now you have these questions. Say question number one: a pressure gauge with the measurement range of 0 to 10 bars has a quoted inaccuracy of 1% of the full scale reading. What is the maximum measurement error expected for this instrument? Uh, so 1% of full scale reading means 1% of 10 bar. That means maximum maximum value of error that can be uh, expected is 1 by 100 into 10, that is 0.1 bar. Fine. So this is the maximum value of measurement error. This is not the uh, because error arising because of other factors like inaccurate uh, reading, ठीक है, by the observer, or because of the environmental effects extra that are not taken into consideration while solving this question. ठीक है, जो आपका system है, it has been designed for an inaccuracy of 1% of the full scale reading. That means because of the instrument की खुद के error की वजह से जो maximum value of error होगा, that will be 1% of 10 bars, that is 0.1 bar in this case. The question states you have been given the figure. The values of these resistances: R1 is 400 ohms, R2 is 600 ohms, R3 is 1000 ohms, R4 is 500 ohms, R5 is 1000 ohms again. The voltage across AB is measured by a voltmeter whose internal resistance is 9500 ohms. What is the measurement error caused by the resistance of the measuring instruments? This is your circuit. This is your circuit. So your job is to find out the Thevenin's equivalent. So once you find out the Thevenin's equivalent in this fashion, will be the Thevenin's resistance. ES is the Thevenin's voltage. You do not need to calculate the value of ES. You only need to find out this RAB. So once you are done with this, uh, once you get this Thevenin's equivalent, you can see that IM will be equal to E naught divided by RM plus RAB. Right? I is equal to E naught divided by RAB plus RM, and EM is equal to E naught times RM divided by RM plus RAB, which implies EM by E naught is equal to RM divided by RM plus RAB, which implies 1 minus EM divided by E naught is equal to 1 minus RM divided by RM plus RAB, which is equal to E naught minus EM divided by E naught is equal to RAB divided by RM plus RAB. So percentage error will be RAB divided by RM plus RAB multiplied by 100%. ये आपका सर्किट है, इसमें डिफरेंट रेजिस्टेंसेस दी हुई है. There is a voltmeter connected across AB. That's actually measuring the voltage across AB, but you need to find out the measurement error because of the internal resistance of this measuring instrument. तो उसके लिए पहले आपको थेवेनिन इक्विवेलेंट निकालना है. तो थेवेनिन इक्विवेलेंट reduce the circuit in this fashion. So for this, that means actually you have to find out RAB from the values of these R1, R2, R3 and R4. They are all given to R5. They are all given to you, as well as RM is given to you. So once you find out RAB, you can see that IM is nothing but इसके across जो भी voltage है divided by this resistance, and this voltage then will be nothing but E naught times RM by voltage divided by E naught times RM divided by RM plus RAB. So इसी इक्वेशन को अगर मैंने 1 माइनस दोनों तरफ से किया, सो यू विल बी बेसिकली गेटिंग आउट परसेंटेज एरर इक्वल टू दिस. सो RAB डिवाइड बाय RM प्लस RAB. RM तो आपको ऑलरेडी दिया हुआ है, RAB आपको using Thevenin's equivalent circuit you have to find out the value of RAB. So find out this value of RAB using the Thevenin's equivalent circuit. Fine, so do that and let me know.